Python. We are we are delighted to have our guest speaker again, Ms. Elsa Sharu Johnson, to take over the session.
Thank you, Saraswati. Uh, I hope I'm audible.
Yes, ma'am.
Yes, and I'll increase the screen. I'll zoom out the screen. It's visible, right?
It's visible, ma'am.
Okay. So today we'll be looking about pandas actually, data manipulation using pandas. So pandas, it's an open source Python package providing high performance, easy to use data structures and data analysis tools for Python programming language. Okay, so it's derived from panel data and it is highly optimized for performance with critical code paths written in either C or Python. So its library features are like data alignment, reshaping, merging, joining, filtration, and pivoting, and label-based slicing, fancy indexing, etc. To know more about the Pandas functions and all, you can go see the official Pandas documentation. I hope you can see that there in your screens. Pandas documentation is there, and everything about the Pandas getting started, user guide, API reference, everything is there in this particular site. You can refer that. Okay, so first I'll start with saying about installation of the libraries. So it's like a pip install of pandas. If I give that right now, it will install the pandas library. Yes. So after first installation, you can comment that line and keep it there. So before starting, you have to just look how's your system connected. If it's connected to your Python 3 Google Compute Engine backend. Okay. And next, we have to import the pandas file. Here I'm using the specific name as PD. So I'm importing pandas as PD. And likewise, earlier, NumPy was imported as NP and Seaborn as SNS. So Seaborn is a data visualization package. So it is presently being used for data only in this particular notebook. Later, when we are learning visualization, we'll be seeing the different visualization methods that Seaborn is having. Okay, so I'll just import these things. Now, Pandas series and indexing. So we'll learn about Pandas series, which is a one-dimensional ND array, and indexing of that. Okay, so I have given these three names as countries and these capitals, and I'm forming an array using the capitals. Okay, I'll run this program. After that, I just want to see how the Pandas series as well as the list work in the Panda series. I mean the array as well as the list work in Panda series. Okay, so first using Python list, I'll be creating a series. So I'll just keep the chat window also open. Okay, so pd.series, and inside that, this is the syntax for creating a Pandas series, and inside data I'm giving like capitals. So capitals is a list of capitals given. It's a Python list. Okay, so using Python list we can form a Pandas series. So Pandas series is shown like New Delhi, Paris, London. Okay, now we can also form a Python Pandas series using a NumPy array, and I have formed a NumPy array and given the name ARR. So using that NumPy array, I'm forming another Pandas series, and this is the same as which was created using a Python list. Okay. Now, next we'll see if a dictionary can be used to make Pandas series. So a dictionary is given. I have given dictionary like A, B, C, D, E, F up to H are the keys, and the values are like 10, 20, 30, 40 up to 80. So I'm giving like pd.series data equal to ticks. Okay, so if I run that, then I can see that it will give the data type as int, and the keys as well as the values are coming here. Okay, now if I want to create a Pandas series using capitals as well as countries, so here the difference is like the data will be capitals and the index will be countries. Okay, so index means it comes at the left side, which is used to identify the things. Okay, so here the index, earlier it has come as 0, 1, 2 if nothing was specified. Here we have specified like index should be countries. So India, France, England has become the index here, and the capitals has become the data of that one. Okay, so this are Pandas series. So next we look at how to index the series. Okay, now again I have given the dictionaries as input, and I have formed a Panda series and stored it in my series. So I'll just run this program and see what's the output. Okay, the output is obtained like this. So I just want to get the first element. Okay, so here the indexing is like ABC up to H. So the first element, now the Python indexing will be starting from 0 itself. So if I give like my series in square brackets 0, then I'll be getting the first element. Okay, so 10 I'll be getting. Hmm? Okay, then even though the difference is that even though we pass explicit indexes to the series, we can still give the normal indexing itself to extract an element. Okay, okay. Then the next thing is like if the things which we had done in the previous class itself, like accessing the starting element till the third element. Okay, if I run this one, the concept is same only, just everything that is still there will be displayed. Okay, and if I give like 3 to 7, then I'll be getting, this is the zeroth one, 1, 2, 3, from D to 7, 3, 4, 5, 6. Okay, 7 won't be included in this case, so we'll be getting up to G only. Okay, next, now we are trying to get the elements using the indexes that we have specified. Okay, earlier we have accessed using the Python indexes itself. Now we are using our specified indexes. So A, B, C, if you give like that, then the indexes which we have specified will be coming. Okay, now I think you can get a small difference in that. Can you tell me what's the difference in there? I'll be looking at the chat window. Can you tell me one difference which is there in the explicit indexing and the implicit indexing?
Ma'am, implicit indexing.
Yeah, can you tell me the difference between, okay, I'll form one more of these two actually. How this value is coming as A, B, C. If I have to get the same values in Python indexing, what should I be giving? 0 to, you just fill this value. Include, Shiva Prasad has given include the last element. Yeah, so what should I be giving here? I want to get A10, B20, C30. Okay, so for that same, yeah, 0 to 2, if I give, what will I be getting? I'll just give, okay, you just see what happens. Okay, what has come? You understand the difference now? Yeah, 0 to 3 you have to give. Okay. Okay, this way. So I have to give, I'll give 0 to 3 and the same value will be obtained. Okay, now I'm just trying to add these. Anyway, the same result will be coming only. Okay, my series plus my series I am just adding. So it will give element wise mathematical operations. Okay. Now, we are moving on to Pandas data frames. So before that, I just want to know if everyone is familiar with the Pandas series. If anyone has have any doubt, please tell me. I'm not seeing any message in chat window, so I think it's okay.
Ma'am, data and copy names are included, ma'am.
Data, can you tell me where it is? Didn't understand your query. Can you tell me once again?
Ma'am, series have six values, ma'am. Data, dtype, name, copy.
Okay, so what you want? You want to know about those things, sir?
Yes, ma'am.
Okay, I'll be telling. You just paste that in the chat window. What you want? I'll tell about that later. Okay.
Okay, ma'am.
Keep it in the chat window. Okay. Okay. Just we'll move on to pandas data frames. Who has asked that actually? Shamala. Oh,
Audition.
yeah. Can you tell me what you want to know about?
Ma'am, I chat.
Okay, data. Data is it is the way in which you have to give that one. I mean, this data. This you meant no? This is
O-
where we'll give the data actually.
Okay, ma'am.
Yeah. And data type, you can see as the which data type you are giving inside that series. Okay. If anything you want to know about the specific thing, you just need to place your cursor on top of that keyword actually. Okay.
Okay, ma'am.
Okay. Then copy and name, what you mean? You want to copy a series, sir? What do you mean by that?
Ma'am, copy true or false.
Copy true or false? I didn't understand that. Okay, I'll get back to you later. Okay.
Okay, ma'am.
Okay. Yeah. Now next we'll move on to pandas data frame. So data frame are 2D structures having data aligned in tabular format, and the data is aligned in rows and columns and can store any data type like int, string, float, and boolean. So if we want to create a data frame, first now here I'll be giving like some fruits name I'll be giving and storing it in fruits, and I'm forming a data frame. So this data frame also, it has these many um, input values. Okay, this many input values can be given to that, and I'm giving fruits. Fruits is a list actually now. I'm giving the data as fruits. Okay. And I'm specifying the columns should be like given as fruits. Okay. So I'm just outputting the fruits.df, and I'm seeing like the column name will come as fruit, and apple, banana, coconut, and dates. They'll be coming as the column values. Okay. And it will be automatically assigned the Python indexing. Okay. Now we can form a data frame using nested lists also. So this is a type of a nested list. So here Rick 60 or positive, I'm giving like this. Okay, I'm giving a set of values like this, and using this I'm forming a pandas data frame. So pandas data frame normally it needs only some data and then some columns. Okay, so these columns should be like the first one is of name, next one is age, and next one is blood group. So I'm just specifying that, and then I'll output this data frame. Okay, so it will come as Rick, Morty, Summer, Beth. They'll come as the age, and come as the name, sorry, and then age will come as 60, 10, 45, 18, and blood group will come as this thing. Okay, this we have given. Now we have seen nested lists. Okay, now if we give dictionary, we'll give like name is Rick like this, age and blood group if we give like this, and if a dictionary is present, we just have to give data equal to people only. Okay, we don't have to specify the column name. It will automatically give the column names as the dictionary keys itself. Okay. Now, if you want to see the people underscore df, that is our respective data frame. That data frame's dimension is coming as 2. Okay. Now, so about data frames, till what I have told, I hope you have understood. Has everyone understood? Now we'll move on to an important topic actually.
Understand, ma'am.
Yes. Okay. Now
Ma'am, key values and index are same, both only, ma'am.
key values and the
Index.
index here, separate indexes Python will be giving actually. We can specify indexes as the key values itself. I'll be showing that later. Okay. That also can be done as I have shown in the series.
Okay, ma'am.
Okay. Yeah, okay. Now loading the files into a data frame. Okay. So this specific thing can be done many different ways actually. So here and here now we are using Collaboratory as our platform. So in Collaboratory, the ways in which you can read the files are, I'll be telling each one now. So is suppose your data set is a CSV file. Okay. So if you want to read a CSV file, you can give like PD. PD is how we have imported pandas. Dot read CSV. Then file path. If your specific file is given as a what as a web page. Okay. So I'm just going with the particular file named supermarkets.csv. Okay, I'm going to work with that specific file. So what I have to do is just search supermarkets.csv, and you'll get many different sites. Okay, so in these you have to look. Okay, you can go at GitHub or you can go at Kaggle. Okay, these two are places where you can get data sets. Okay, so here you can see that data set. So to access this particular set, you can go to click raw in that, and you will get the raw values of that particular data set. Okay, and after that you will see this particular address, right? You can copy this address, and then you can place it here. Okay, that is what has been pasted here. HTTPS row, this one. Okay, so this is one of the methods. Okay, now after placing this, you have to see whether it's coming or not. Okay, I'll just run and see. Okay, this is coming. This particular data set which is given here is coming in this form. Okay, now another thing is like, I'll just run this particular thing. This is for uploading from your computer, your device. Okay, so if I run this one, I have to choose the files from my device. Okay, so here I have given like I have anything. I mean, I just get the CSV file first. Okay, that is there, and okay, it is being saved here. So where it will be saved is like this one. Okay, so I had already downloaded it once, so I'll delete one file actually. So this is the file which is needed now. Okay, now then after that I'll just give this command like supermarkets.csv. I'll just read this one to csv underscore df1, and I'll just run this thing. Okay, so when I run this, the same thing which was given using the web page is obtained here. Okay, so this is how you load CSV files. Okay, sometimes in some cases you will be getting Excel files also as your data set. Okay, so if you want to read Excel files, you have to give this specific command, read underscore Excel, and this is the web page of getting supermarkets.xlsx. Okay, so this also can be searched, and if you search, you'll get in GitHub. Sometimes you get some things as in Kaggle, you can download from there. So you can get these things like that, and in Excel, maybe you can specify your sheet name. Okay, if many different multiple sheets are there, you can specify the sheet name, and you can load your data from there. Okay, so if you run this thing, you can see the same file obtained. Okay, so this is how you'll load Excel files. Now if in some cases this is the same thing actually, but the problem here is like this specific here supermarket semicolon, this text is the values are separated by semicolon. Okay, so if I give like that, simply if I load the file, then I get values like this one. What is the difference here? Your values are separated like separated by semicolons. Okay, so to avoid that, you just have to give separation equal to everywhere. If when you type, the Google Colab will give you some suggestions, you can go with that also. So if you give the specific extra thing actually, I mean, if you give like sep is equal to semicolon, that means you are specifying that your data is separated by semicolons. So if you give like that, then you'll get it separated like you have seen earlier. Okay, so these are the methods in which you can load the data. Okay. Likewise, you can have read JSON. If your specific data set is a JSON file, you can do read JSON. Then in some cases, you will get your data set like a .sav file, which is usually viewed by the SPSS software. So in that cases also, that specific files can be read. So what you have to do is, whatever data set you get, you can just search it, and you can just see how to read data files using pandas. Okay, you'll get the specific syntax. Now TextDF, if you want to get a specific state which is named as CA. So this is our data set. Okay, ID, address, city, states, country, name, and employees. Okay, so this employees means the number of employees actually in the data set. So if you want to extract a specific state known as CA 94114, then you have to give, like, in the data we have stored in text underscore df, and in that we are specifying where the state equal to this one. So if you run this thing, then what you will get is like wherever the state is similar to this particular word, okay, this particular string, it will show those rows. Okay, I hope I'm audible.
Yes,
um,
ma'am.
okay, now if you want to see wherever the names end with shop, okay, in our original data set we have some names in the name column, like ending with shop, okay. So but the thing is that here the shops, the first value is coming as uppercase, okay. So for that, I mean, we want to find how it ends with it. When ends with shop, we want to find those rows, but the thing is that everything is not in lowercase, so we'll first give that name, okay. We want to get that name, so we'll give this command, and in that we'll make it str.lower. This is the command to make it lowercase, and after making it lowercase we'll then just give str.ends with shop, okay. So when we give it sequentially, you will get it like wherever the name is ending with shop, okay, you will get it like get these rows, okay. So if we don't specify this str.lower, it won't look like that, because the first letter is uppercase here, so it will return nothing actually, okay. Now this is another thing, like if you want to replace the string there present, like I want to replace shop with Shopee, okay, like that I want to replace. So what I have to do is that I have to specify where to store that thing, and I have to specify where I'm making the change. So I'm making the change in the name column, and in that string I'm replacing shop with Shopee, okay. So if I run this, what I can see is that wherever then shop was there, Shopee has come. Okay. So can you tell me what will happen if I run this thing again? I've just told like the initial thing is like shop like this. So if I am run, I have run this one time, okay. And if I am running it again, what will come here?
Shopee.
Okay. So, but I'll just show you, okay, what is coming. Yeah. So I'll run this, means it's already run. I'll just display this. Okay, you see, it will be replacing only the word shop. Okay, so earlier when it was changed as Shopee, it still has a shop word. So instead of that shop word, again a Shopee has come. That's why it's repeating like this one. Okay, I hope you understood. Now, next I am going to change the employee's name, employee's number. And in this case, I just want to replace the number 25. There is a number 25 there. I want to replace it as 50. Okay. So here, replace in order to replace to work, it has to be converted as a string. Okay. So I'm just first converting the employees thing to string as type string. Okay. Then after that, I'll replace the string with 50, and after replacing, I'll be converting it to int. Okay. So if this operation is done, and if you find the what has happened to it, you can see that 25 got changed as 50. And if you run the type of this one, you can see that this column will have int only. Okay. So these are the ways of loading data frame. Now we'll see the different attributes. Okay. So similarly, that's the same way I am reading the same file to data. This is the same data set itself, and I want to see what is the resolution of the data frame. Okay. So I'm giving like data.shape. Okay, so this specific data set has 6 rows 1, 2, 3, 4, 5, 6, and 7 columns 1, 2, 3, 4, 5, 6, 7. Okay, 6 comma 7 is the shape. And next, I want to see the data type of columns. Okay, so I'll just give data.ttypes. Okay, so what is coming is that the id is, we'll just look at the data once. So id is consisting of integer numbers, address, city, state, country, name. All these are new string values, and and the employees is again an integer. Okay, so what here it's displayed like the id and employees, it's an integer, then others are coming as object values. Okay, so this is another attribute actually to find out some information about the data set. Okay, the first one is like d type. Next one is like info about our data set. So if we run that, it will show like what all columns are there, how many non-null columns are there. I mean, if there are null values or non-null values. So here everything is non-null. Then it will also display the data type. Earlier when we give d type, it's only it just show how the data type is there. So here we can see each and every information about our specific columns. Now if you want to, okay, I'll go about that later. Now I'll just see the total record in columns. This shows how much values are present in each of the columns. Okay, now to get the index range, this I'll be going a little rapid, so that because this can be understood easily. So start is 0, stop 6, and step is equal to 1, and data dot columns will give the column names. These are the column names of our data set. And if we want to give the column, if we want to set the column as index, then we have to give data dot set index key is equal to name. That means that is what has been asked earlier. So like this is the name actually, Madeira Ready Shop Super River, this is the name. So we want to set this name as the index of our data set. Okay, so if that is to be done, then what we have to give is that data dot set index, we have to give the keys as the name. So if we run the specific cell, we'll get like the name is given as the index. Okay, so we are defining the index of that data frame, and id, address, city, state, country, employees, those all are there as earlier. Okay, so I hope the attributes are clear. If it's clear, we'll move on to the access, add, and drop operations.
Yes, ma'am. Clear, ma'am.
Yes, okay. So next, my voice is clear, right? I think there is some disturbance. Sorry for that. Um, so I'll be loading the same data set. Okay, supermarkets.csv itself. And I'm running this and loading it to data. So I want to access this particular column. Okay, so I'm giving like data of address. So this specific column will be coming. So I've loaded again once. So the indexes is not coming as I have given earlier. Okay. Earlier I have changed the index as the name, but now it's not coming here because I've loaded it again. Okay. Now, if I want to see multiple columns, then I just have to give data. But the thing difference is that you have to give the multiple columns inside square bracket. Okay. And then you have to give it inside another square bracket. Okay. Then only you can see 2 columns. Now, adding column to existing data frame. So, if you are giving like want to give the you want to give the salary of the particular employee to this data frame, then you have to give data salary. This is the new column. And if you run this thing, it will be added to that. You can see the salary is added to the specific data set. Okay. Now I want to create a new column with the data from the existing columns. Okay. So I just want to know the total salary that is given to these much employees. So the employees number is here, salary of one employee is there. So if I multiply these two, I'll get the total salary. So I am defining my new column as that, like this. Okay, total salary equal to data of employees, data employees, and into data salary. So it will be forming a new column, and this new column will have the data of um, will have the data of total salary, which is a multiplication of these two values. Okay. Now, next we'll move on to deleting rows and columns in a data frame. So I'll just see what is data, and so this data has the total salary value also till now. Now I want to drop one of the columns. Okay, so in this data set, this ID, it doesn't have any specific information. So I'm trying to drop this ID. Okay, so this dropping can be done like two methods. Okay, so first I'll be trying like I'll be giving drop this labels id and in place is equal to false. Okay, so if I do like this, what's the advantage is that you won't see any difference in the original data. Okay, I'll just comment this thing. You can just visualize only. Okay, when you visualize the specific method data.drop, I am giving labels is equal to id and in place equal to false, then it won't be changing anything in the original data. It will only be displaying excluding that particular column. Okay, will be just displaying. But if you want to make any original changes to the make any changes to the original data, you have to give like true. In place should be given as true. So if you do this thing and if you display the data also, sorry, I'll run it I'll run it once again. Okay. Please wait. Okay, so I'll run this thing again. And now what has happened is like the ID is being removed. Okay, and it's removed from the original data set itself. So if you run this two times, if you run this command two times, you will get an error. Okay, now what you have to do is like, I'm just trying to drop the first record, but here I have given as in place is equal to false itself. So if I give it like that, I'll just be seeing that the first record is removed. It's not originally removed, because if I run it again, I can see the first record, which is there itself, present there itself. Okay, so in place you have to check whether this option is true or false to see whether any real changes have been made to your data set. Now, I'm going to create a new variable where name column is set as index. Okay, so if I do like this, the name is set as the index. Now, I want to drop this label. Okay, I want to specify like, I'm not specifying a specific row. I just want to see where this Sanchez is present and I want to drop that row. Okay, drop the record containing that row. Okay, so if I give like that, now this Sanchez is removed here. Only thing is that the original data is still intact. no changes have happened to that original data. Okay, so I think till now it's clear. If there is any doubt, please tell me.
No, ma'am.
Okay, so I'll be moving on to data frame indexing. Now, for this one, I'll be using the supermarkets.csv, and now I'm specifying like the index column should be ID. Okay, earlier I haven't specified like that. Now I'm specifying like I have to make the index column as ID. So if I do now like that, now the index, whereas earlier the index had come like 0, 1, 2, 3 up to 5, here it's now coming like the ID is made as the index. Okay, so you'll see the ID was starting from, it has started from 1 to 6, and so now this is the indexing. We are specifying the index. So when we are specifying the index, there are two methods of selection, okay, for indexing. So ilog is like normal Python indexing only, selection by normal Python indexing. But if you are using log, then it's indexing with user specification. Okay, so I'll show the difference between these two right now. So first I'm giving ilog. This is the Python integer location based indexing. So Python integer location based indexing is like 0, 1, 2, 3, 4, 5. Okay. User based indexing is now from 1, 2, 3, 4, 5, 6. Okay. So if I'm giving ilog 0 to 4 and 1 to 3, then it will be taking like all, earlier it had take for numpy as well as earlier we had done. Okay. That means the 0th row, and it will be taking up to the 4th only. That means 0, 1, 2, 0, 1, 2, 3. Okay, so we'll see the result of this one. So here, and I have specified what the columns also. Columns should start from the first column. So the first column, this is the 0th column, the first column is the city. Okay, so city, and in that itself, I have specified like how many rows? 0, 1, 2, 3. That is 4 rows should be coming. And columns are like 1 to 3. That means first column and second column. So this is in ilog, the ending number will be excluded. Okay. Now, in another example, like I'm selecting all the rows here and the columns from 0 to 5. If I run this specific thing, I'll be getting these values. Okay, just I'll run and show you. Now we'll move on to log. Okay, this is the accessing a group of rows and columns by their label. Okay, so here we have given the label as the ID. So in this case, if we are giving market underscore df dot loc from, I'm giving like 3 to 5. Okay, so if it was ilog, only the third and the fourth row would have come. Okay, but here 3 up to 5 will be coming. So I just move on to the original data once more. So this is the original data, market to underscore df. Okay, so for displaying that, I'll just run that once more. Okay, this is our data. So here 3 to 5, 3, 4, 5 also. 5 also will be included, and we have to extract the address column. Okay, so if we run that, what will happen is that the fifth one will also be coming. Okay, if this was an ilog, if you had given ilog here, and at that time we have to give the Python indexing here itself for columns also. If you are given ilog, then the fifth row won't be coming. But the difference here with log is that whatever you are specifying, it will be coming. So here we have given like 3 to 5. So 3, 4, 5. These 3 rows will be coming. Okay. Now I've just given it for once more for displaying. Now if I'm giving like 1 to 4 and the columns from address up to country, Then these all columns and 4 columns will be coming. I mean, the country column will also be included here, and the fourth row will also be included here. Okay, this is what's happening in case of lock. And I'm giving like all rows will be should be there and columns from state. So this much will be coming. Okay. So this is how Python indexing iLock and lock works. Okay. If it is clear, we'll move on to append, contact, concat, and merge operations. I hope you're clear with this.
Yes, ma'am.
Yes, okay. Now we'll move on to the append. Okay, so I'm giving specifying a new one, data underscore dict, and I'm specifying ID, name, and language. Okay, just like these are the ID numbers of these persons, and they know these languages. Just I have defined like that. So I'm forming a pandas.data frame, and I am specifying that this is the data. Okay, so data frame has all these um inputs. Okay, this can be given. These are the values which can be given in the function. So I'm just giving the data only. Nothing more is needed. So I'm storing it in the df1. So I'll get the ID. I'm getting the name and the language. I haven't given any ID to be named as the index. So the Python normal indexing will also appear here. Okay. Now I want to give the df2 as this specific value, where I mean I want to add another frame. Add another data frame that contains only one row. So I have given like this. So it has the index values 0, ID is 6, name like this. Okay, I'm specifying like this and giving to df2. Now our operation is like I want to append this df2 to df1. Okay, if I run this, I will be getting the like this. Okay, now I want to ask you one thing. Do you observe anything, any mistake here in this data frame appending? You can reply in the chat window also.
I'm lost index 0.
Yes. The last index has started again from 0. Okay. So if you give an append directly like this, it will be restarting the indexing. Okay. So what you have to do is that you have to give ignore index equal to true. Okay. So here in append, you can see like append, which one has to be append. Other is the other frame which has to be included. Ignore index, normally it will be false. That means index will be restarted. Okay. So here, if you give this as true and then give it to df3, you will be seeing like here the indexing has restarted from hasn't restarted, it will be continuing the indexing like earlier. Okay, now concatenating data frames. So here I am again loading these two values. Okay, so here I put name as abcd itself, and I have put in the other data set I have given like bcdef. Okay, and some little similarities and differences are there between these two. We'll just see. We just create data frame using both those sets, and we'll see them separately. So the first df1 is like id, name, and okay, subject, and df2 is like id, name, subject like this. Okay, so if you want to concatenate, okay, I am going to concatenate this one in the row axis. So if I do like this, then here also the first one will come like this, and then again this one will come like this. Okay, so this is the indexing according to not indexing, concatenating row wise. If you want to give column wise, what you have to specify is like axis equal to 1. Okay, so if you do that, you can see like this next one, the second data set will be coming as the separate column. Okay, now moving on to merging data frames. So I just given a full documentation file here. You can go check there for knowing what the different um, keys in that key different parameters in that merge function is. So these all specific, I mean, description about all these parameters are given. So the different types of join are like left join, right join, outer join, inner join, and cross join. We'll see all these with examples. So I have created one new data like employee ID, employee name, and subject. Okay. Now the next data set is like I have created like department ID, department name, and subject. Okay. Now I'm giving these to df1, df2, just forming data frame like earlier, and I'm displaying first one. So employee ID, employee name, subject, just given like subject 1, 2, 3, like that. And df2, I'm giving like department ID, department name, subject. That the common column which comes to both data set will be subject. Okay. And in that itself, if you observe these two, here sub 1, 2, 3, 4, 5 is there. Here also 3, 4, 5 is there. Okay, 1, 2 is not here. Extra 6, 7 has come. Similarly, in employee name, A, B, C, D, E is there. In department name, B, C, D, E, F is given. And the employee ID is similar in both cases. Okay, so I'm trying all our types of merging. Okay, these left, right, outer, inner, all those things here. So first I'm trying like pd dot merge. Okay, left equal to df1. That means the left data set should be df1. Right equal to df2. And on sub means which specific parameter, I mean which specific column name we have to merge with based on which column name. Okay, so we are merging based on sub. Okay, so when we are merging based on sub, which all subs are there common, that will be kept, and the remaining data will be added. Okay, so here left is this one. 2, 3, 4, no, 3, 4, 5 is common in both data sets. So these much values 3C, 4D, 5E, these values will be kept from first one, and from the second data set sub 3 has 1B, 2C, and 3D. 1B, 2C, 3D. Okay, so whichever is common there in subject, that will be kept. Okay, now if we want to concentrate on the left data frame. Okay, so on if we want to concentrate on df1 sub values, then we have to specify a how. Okay, this parameter has to be specified, means how we have to merge. So if we are giving like how is given as left, and if you run this thing, you can see that the left data set will be retained as such, and what all values are there in common in the right data set, that will be added. Okay, so right data set didn't have sub 1 and sub 2, so corresponding to that the department ID and department name was not present, so here NaN, not a number, will be coming. So because it didn't have any value for sub 1 and sub 2. Okay, now what will happen if we give how equal to right? Right will come as df2. It will be taking df2 sub values. That means sub 3, sub 4, sub 5 will be coming as usual, and for sub 6 and sub 7, these values, one employee ID and employee name, will be NaN values. Okay, so if I run this thing, so sub 6, these specific values have come as not a number. Now if you want like you have in sets, you'll tell like a union, no? So a union of both data sets, if you want, you have to specify like how is equal to outer. Okay, So if you give like that, you can do like this, and you will obtain wherever the values are not there, you'll get an NaN value there. Okay. Now, then what can be inner? Inner will be like the intersection of the values. So when we run this, we can see that this is the same as which had been done at the first time. Okay. This is the same as when we have given inner also. Okay, so normal merge will give you a value which is similar to intersection. Okay, now we have learned to concatenate, merge, and append data frames. Okay, I hope you are clear till merge append. I'm following with, I'm continuing with data filtration. So here, same data set I'll be loading, and after that, I just want to filter out the employees which are the places where the employee number is greater than 15. So if I give that, I'll get the values. I'll get the values where the employee number is greater than 15. So here it's not greater than 15, so I'll get false. Next one, greater than or equal to 15, it's true. Yes. So I like that, I will get the values. So if I want to filter out the rows, here it just had given the places where it is true or false. If I want to see those rows, then I have to give this condition inside the square bracket. Okay. So now I can see where it is greater than or equal to 15. Now if I want to give two or more statements like this, I want to see where the employees are greater than or equal to 15, as well as where the state name is not equal to CA94119. So if I give this, I'll see like wherever these two statements are coming, okay, together, like an AND operation. So we have seen how to filter out values. Now, multi-indexed data frame. Okay, so I'm just making a custom dictionary like this. Company, I'm giving like Google, Microsoft, like that. Year, revenue, and employees. Okay, and using this, I'm forming a data frame. I'm just defining like this. So I'll get company, year, revenue, employee. Okay. Then I want to set company as well as year as index, and I want to access the rows. So I have to give set index. cmp.tf is the data frame name. Then this is the index, set index. I have to give keys as company as well as year. And I'm giving like in place equal to true. So I am changing the data frame. So if we want to view the modified data frame, I'm giving companies Google, year is there, revenue, employee. Okay. And in Microsoft, in year, so here we can see like in company Microsoft in the year 2009, 2008, the revenue is this much and employees are this much. In Microsoft in year 2009, these are the like, so like this you can view the data. Okay. Now, in this specific case, if I give like this, okay, I just need 2009. Okay, that key itself. So if I run this specific thing, you just observe what happens. So you'll get a key error. So we have changed our data frame like this, okay. We have given two labels. So if you do like that, now it will be throwing an error. So if you want to do that specific operation, you have to give first specify which is your company name, and in that, so LOC is user specified, right? So LOC Google dot LOC 2009. So two times you have to use LOC. Then only you can access that specified column. So if you want the year 2009 of Microsoft, you just have to type that and see in 2009 what it was, what's its data. Okay. So there is another function known as .access. So this can be used for giving like this. I mean, instead of typing .loc 2 times, you can give like key Microsoft level equal to company. So you can see the years of each company like this. Okay. Now if you want to access the year, you can give like this. In access command, key you have to specify is 2009 and level is the year. That means in the year column 2009 has to be taken. So it will give for both for Google as well as Microsoft because that was the starting label. Okay. Now we are using SNS. SNS I have told earlier, it's a data visualization package known as Seaborn. So I have imported it like SNS. Okay, so SNS has a data set named as tips. So this particular tips is in, you can see what it is actually, Seaborn tips. Okay, so I'll just take a Kaggle. I'm just showing what it is actually. So Kaggle is another website where you can do visualize the data sets. So it has these columns like total bill, tip, the sex of the person who is paying for the meal. Okay, so it's like a data set, food service tips in restaurants. So who is paying for that? That is meant by this column. Then if there is, they'll be coming as a party. So if there is a smoker in that party, yes or no. If no, 0, then 1, yes. And then the day which are they coming. These much days are there: Thursday, Friday, Saturday, Sunday. Then time is 0 if it's day, 1 if it's night. That means dinner or lunch. And then the size of party, how many members are there in one party who is coming to the restaurant. Okay, so this is the Seaborn tips data set. So I am loading this tip data set. It's since it's already present, you just have to give load data set. Okay, so I'll tell you, whenever you are getting a new data sets, one thing you have to first do is like you have to see what is in that. I mean, you have to access some of the rows of that. Okay, so either you can use head, okay, or you can use tips dot tail. Head means the first 10 rows you'll be obtaining. Tail means the last row. Okay, so I'll just first load this thing and I'll see what is coming. Okay, so this is the data frame. Now I'm just giving like tips 1. I'll just simply give, and if I display tips 1, then the tail part of the data set. Okay, so this data set is big actually, and I'm just displaying the end values. Okay, now if I give like set index, means the index I'm specifying like sex as well as size, and in place is equal to true. So the values will be coming like female and male, and in that, this means whoever is paying. Okay, and in that the size of the party is coming. So the other columns will be placed like this. Now I want to sort the indexes. So here it will be coming like each of the sexes will come, which is the majority will be coming first. I mean, in that data set, males were paying more, so it has come first, and now it will be coming like this. Okay, the size of the party, and females the size of the party, and the rest will be coming like that. Okay, now I just want to see the key equal to 2 coming in all those records. Okay, the records were key equal to 2 coming. Okay, so I'm just seeing where it is and the rest of the data. So I think this much is clear. I'll move on to group by in pandas. Okay, so again I'm loading, and I'm just giving some operations with that. I mean, just seeing what all things are there. I just want to see where time equal to lunch. This thing will show how many counts are there. So if I run that, how many instances of lunch is there in time? I'll obtain. So this is the command. Okay. Now I want to find where all the lunch time is equal to lunch and its total bill at that time. Okay, so it will show the row values where lunch is coming and the total bill in those specific rows. Okay, so there are 68 instances and the total bill is having float 64 data type. Okay, now what doing is that I'll be grouping these specific columns. Okay, day, time, smoker, and sex. And in those groups, I want to see what all values. Group by means grouping according to some specific values or function. You want to see some things in that specific columns. Okay, so I'll be giving like total bill. I want to see the count of that total bill and the mean of the total bill. And I also want to see count, mean, and sum of the tips given. And I want to see the size, mean of the size. Okay. So you can see, you can understand it clearly if I run this program. Okay. So if I run this cell, you can see like I had given day, time, smoker, sex. Okay. All these things I've taken. So first one it will be taking as day. How many days are there? 4 days are there. Thursday, Friday, Saturday, Sunday. And in that itself, in each day, I'll be taking the time. Lunch and dinner are the different time. Then in each time, smoker or not, and in each that, male or female. So if this particular column is selected, it means that that party has there happened on Thursday, lunchtime, smoker or not, yes, and female. Okay, so how many instances are there? 7 are there, and in that 7, what is the total bill paid by all those 7 members? This is the mean. Okay, now tips, how many people had given tips? That will be the same because if everyone has given, and the mean of the tips paid by them is shown here. Okay, and next one is like size, the total people who had come, and the sum is of the tips actually. And next for size, the mean of the people actually. Some people will be a party of 2, some will be a party of 3, some will be 1. So the size, mean of the size of people have come is given. Okay, so if for example I am accessing Friday dinner and non-smoker female, then I'll be getting like total bill. Only one person is there like that. So the bill she paid is $22.75, and the tip she is paid is like 3.25. So the sum of the tips will be the same only, and she has come as a party of 2. Okay, one more person is there. Okay, so like this you can view the information. Now, if you want to see the time and day, so this I have just taken time and day only. So lunch and day, and I want to see what is the total count. So it will be giving the count in each of the columns. Okay. Now, if I want to see just the time and the mean of all the other columns. So wherever the numerical columns are present, mean can be taken only in numerical columns. So I'll be getting the mean here. Okay. Now next is like total bills mean only I want. Okay. Earlier I have taken mean of all the columns. Now I want only the mean of the total bills. So I have to specify like this. Okay. Next, if I specify like total bill, I want to see the min and max values, and for tip, I want to see the sum. So if I give like that for the specific time, then I'll get like the total bill, min and max values, and the sum given for the tips. Okay, sum of the tip value obtained. Now I'll tell you like a standard method to read a new data set. First, you have to see either the sample head or tail, and next, you have to see the info of the dataset. After that, describe and then group by. This is the standard procedure to be followed. So, tips, if I give info, then I'll get like this is the information about the dataset. Next, I'll if I give the described data, now I'll get a specific information. This means the count, the number of unique values. So number of unique values, here it is 2 because only two male sexes are there written in that set. So male as well as female. In smoker, yes or no. Day is like 4 days are there. So there's are 4 unique values there in day. Now top means in that data set how many values, I mean top occurring value. Okay, so male is the top occurring value who has come in that data set. So it's written here. Then frequency, how many times that person has that specific unique value has come. Now mean will be coming for numerical column only. So total bill, all these things, this will be mean of those values. This is the standard deviation. Then minimum total bill and maximum total bill will be coming. Next, this is the percentile actually. I mean 50 percentage of the data in that, I mean that minimum, between that minimum and maximum. The 50th percentile is coming at this value 17.79. Okay. Then the 25th percentile is there, 75th percentile is there. Okay. Next, I want to find the value counts of different sexes. Okay, I mean male there are 157 and female there is 87. Okay, now this is the group by method. Is group by understood?
Yes, ma'am.
Okay. This now next we'll move on to the data frame operations. So here I have shown this data frame earlier itself. So here I'm just showing the score, and next what I want to do is I want to change the score based on a particular function. So I've just given a small function here. It's giving like if the x value is giving a remainder of 0 when divided by 6. I mean if it's divisible by 6, then you have to check if it's divisible by 18. If it's divisible by 18, then you have to give like x into 3. Otherwise, you have to give x into 2. If both these if conditions are not satisfied, you have to return the same value itself. So I want to give this specific function to this data frame. Okay, in the score column. Okay, so I'm just giving like x factor like this, a new column, and I'm giving like score dot apply x fact. This is the function. So I'm applying this function in this value. Okay, in this data set. Okay, so I'll be getting a new column named x factor, and in that it will be checking whether it's divisible by 6 and again whether it's divisible by 18. So this is divisible by 6 but it's not divisible by 18, so only x into 2 will be happening, so 120. Here it's not divisible by both, so it is retained as such, and in the last case it's divisible by 6 as well as 18, so that x into 3 will be coming. Okay, this is how you apply functions. Now I want to see how many unique values there are there in blood group, and I want to see the number of unique values. Okay, this is a straight away method. These are the unique values, and these are the number of the unique values. And if I want to see the blood group value counts, I will see that O positive there is occurring 2 times, A negative is 1 time, and B positive is 1 time. Now this is another function, and I'm giving another way of giving this function. So I just have to give earlier apply function I'm giving, and I'm using this lambda parameter. So this lambda, okay, this is used to give this specific operation x into 2, and if I give like this instead of giving this times 2, okay, I mean the same operation can be done using this also. That's why I have given this as commented. So the second thing we have observed earlier, the first thing will give the same functionality as the previous one. Okay, so score times 2 will be giving the score value into 2. Okay, now if we want to sort the values in the score in ascending order, then you can give like ascending is equal to true and using this sort values. Okay. Now, if you want to sort the values based on score as well as X factor, now then you can give it like a list value. Okay. And give it a list. Okay. Now we have seen many things on the data frame. Next is time series operation. There's 10 minutes more actually, so I'll just load this. Okay, I'm loading a new data set. If you want to see what this data set is, you just have to copy this, place this one, and you can select from anything that's available. I mean, description more will be obtained in Kaggle, so you can select in Kaggle. This is a air prediction. Okay, it's a UCI dataset. Sorry, description is not available in Kaggle. This is from UCI machine learning repository. Okay, so here that dataset value is given. Okay, date, time, everything about that dataset is given. So I have just taken it from GitHub actually, and I'm storing it in air underscore df, and I'm giving like air underscore df dot head. Okay, so you just observe here the date is like, is it day, month, and year, or month, day, and year? Some confusion you might be having. Okay, so if you have that confusion, what you have to see is like you take some more values from that data set. Okay, so just I'll give like maybe I'll take a sample, not like a head. I'll take a sample of about 10 values. And if I run that, you can see 20 is coming. So anyway, this is first one is the date value. Okay. Now anything else? These are the values. You can check what all are these things in the machine UCI machine learning repository. So here I'm just obtaining some information about that data set. 9357 values are there. All are non-none values, nothing is there which is missing. Then I'll just describe those values, and I'll see the count, mean, standard deviation, all these values. And if I take a sample, I have run it already. So next to this thing is that when I check this one, you can see that the date as well as time is coming as an object value, like just as giving us a category itself. It's taking it as a category. Okay, but it shouldn't be like that. It should be date as well as time. It should be in the format of date and time. So we have to take this specific command actually, pd dot to date time. Okay, so in using this, we have to specify that the date column is in the date time format. So we'll give like argument rdf date, and format I'm giving like this. Okay, so I'll just see what happens. Okay, so one thing I have done wrong here is like I've given like month, date, and year. Okay, how was our data actually? It's like date, month, and year. Okay, so what you have to do is like I have to change t as well as month. Here also they are telling the error here does not match the format. Okay, okay, if you change it like that, you can see.
Ella,
Yes, ma'am.
it's taking more than an hour. Have you informed the students that you are taking more than an hour?
Yes, yes, ma'am. Yes, ma'am.
How long it will go?
12:30 only. I'll
Okay,
finish now.
okay.
Okay. Okay. Likewise, if you want to change the date time format, the time will be changed as okay. It's also showing like the time format was dot will be there. I mean, simple full stop is there, but here I am giving like colon. Okay. So here also I have to change like dot, and here also dot. So if I run that, I can change like this one. Okay, time type has come. Now if I want to find is there a leap year? Yes, wherever the leap year is coming, it will give us true. Okay. Now, if we want to extract only a specific year, okay, first I'll just show, specific day, month, or year, like that. I'll be giving like this, and I want to get the number of unique days and unique month and unique year. You can try with these things later. Actually, I'm just showing here. The number of unique days will be 31. This is the command for getting that. Okay. Now I want to get wherever the date is less than this particular value. So I just give timestamp this particular value, and I have to give pd dot to date time, and I am giving like less than this timestamp dot shape. You can play around with this code, and whenever you get an error, you can see wherever you are coming wrong, and you can correct it, and you can do. It's very easy. And if you see where all the values, I'm just giving like less than this particular date, and I want to see where all those values are coming. I'm just um, given like this, and it's displaying like this, and I am just want to see what's the shape. So here in all this much values, the date stamp, the date values are coming less than 1/1/2005. Okay. So this is how you do that. Okay. So this is a conclusion. Like it's pandas. It's great for doing analysis, and it's an open source library. It has a wide range of fields and built on packages like NumPy and Matplotlib. And okay, these are about pandas. Okay. So I hope everything is clear. If you have any doubts, you can ask that now.
Pandas having panel also. Panel.
Pandas having there are
Pan.
many packages actually. This what pandas is known as panel data actually.
Yes, ma'am. Panel has three-dimensional.
Yeah. Okay. Yes. Yes. But now we are. Pandas. It's two-dimensional data that is only required for many of the functions that you use. Okay. For reading data sets and all, pandas is used. If you need that thing, specific thing, you can go for that package. Okay.
Okay, ma'am.
Yes. Any other? Is there anything in the chat? Okay, I don't. I think there is nothing in the chat window. Do you have any other doubts?
Ma'am, kindly send the Google collab link, ma'am.
Of this one, no? Notebook.
Yes, ma'am.
Okay, I think your sir will be giving that at the end of the lecture, I think.
Okay, ma'am.
Yeah. You worked with that panel data?
No, ma'am.
No.
Yes. Right now we
Yes,
are not.
Elsa, you can even invite them, like if they want to come and work under us, they can apply and come for internship if really they are knowledgeable in AI. So after the last lecture, I just want to know the list of students who are attending all the sessions and their background. And if there's anybody is interested to work under internship with us, you can explain about our work, what you're doing presently.
Yes, ma'am.
So it's a call, it's an open call to all the students who are attending this lecture series. So we have internship provision both in our lab as well as we have Center of Excellence of AI, which is funded by Tata Consultancy Services, Tata Consultancy. So we have both paid as well as unpaid interns to work on AI problem. The problem can be anything. So Elsa is working on biomedical, but it can be
Kana.
pertaining to your field of study also. So if you want to do in our department, you can do in AI biomedical. So very soon call for internship will be available in our website. You can watch our website from Tata Center, you'll be getting internship call, and we have already floated an internship call that is only for NIT student. But if you're really interested, if you're knowledgeable, please keep in touch with Dr. Ms. Elsa Johnson. So next session, after the end of next session, she'll be briefly telling about the work, what she's doing presently, what are the work we are presently carrying out. And who's coordinator, please get us the list of students who are attending all the 4 sessions, Elsa. Please get the list and save it with you.
Yes, ma'am. I'll get from Professor Hema Kumar.
Oh, he is Hema Kumar, is the faculty there? Okay, thank you.
He's coordinating everyone.
Okay, thank you. Thank you. Thank you then. Thank you, everybody. Elsa, he will conclude.
Sir Hema Kumar, sir?
Yes, ma'am. Let's conclude this session if you are done.
Okay.
Okay. It's my privilege to propose a vote of thanks on this occasion. On behalf of Puducherry Technological University, I extend a hearty thanks to our chief guest, Ms. Elsa Sharu Johnson, who spared her precious time to give this session. Today, we had an opportunity to learn more about data manipulation using Python and the data analytics with Python once again. And this will surely encourage us to learn more on this topic. Thank you, ma'am.
Thank you. Thank
Okay.
you for giving me the opportunity.
Okay, ma'am. Dear participant, I kindly recommend all to fill the feedback form shared in the chat box. Once you've done, let's join the next session on upcoming Saturday.
Any further clarification, you can also mail to Elsa Sharu or WhatsApp to her number. Okay, thank you all. Elsa, I'm leaving. Thank you.
Yes, ma'am. Thank you, ma'am. The link, Shamala, currently the internship is just for NIT students, I think. The link is there in NIT internship itself. So you can search the website. I think later it will be changed. Okay, so next week I'll be pasting the link. Okay, and
Okay,
Kanak
ma'am.
also, yeah, and Kanak also. Okay, we'll see about that next week. Okay. Okay, thank you. I'll be leaving now.
Thank you, ma'am.
Okay.